thanks to camp. Otherwise, we would have had a possible robot decapitation.
Kara, can we get the red light on too, please?
Okay, it'll just take me like a minute. Thank you. More duct tape. I just need to start my Python program and I'll be there we go. So friendly reminder that there is a Maker Faire coming up next month. Oh, I should probably turn on the speaker maybe. Anyways, so I'm getting these two ready for the next month's Maker Faire. And what they are is, I've done some dancing robots before, but this is a bit of a redesign, and I think I brought this one last month. So I made her a sister, and I made some changes with her. This time I didn't put fabric on there because I thought it would be nice to kind of explain to the kids. Yeah?
Move the one on the left a little bit to the left, our left. Okay, our left, that one, because we can't see the screen.
Oh yeah, I know you want to see the YMCA at the end.
I wasn't sure if it was part of the demo.
Oh no, that's good. Thank you. It's okay if you dance along.
Come on, you know how it goes. There you go. Small, 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 small world.
Well, actually, this is to help solve a problem. When you have as many robots as I do in my household to do a Maker Faire, I start calling it the clown car because I have to figure out how to squeeze the robots and my kids in the car, and it just gets to the point of being ridiculous. So I'm like, okay, let's scale stuff down. And so the fact that I can have this all in one box, one IKEA box, is an accomplishment for me. So anyways, so what it is there's a base of the Adafruit kind of curry bot over here, so it's sandwiched in layers. There's DC motors, then I have a couple layers for the power, and then this one has an Arduino Maker, one 1010 Wi-Fi, just because I need all the memory for all those dance routines. So, and you know, would have not cut it a couple years ago, still will not cut it. You know, Mega, typically the scale, but I just wanted to go slower, so I did a PCB with the Arduino 1010, and then on there I also have a little board that's a gyroscope, a accelerometer, a magnetometer, so I plan to work that into the software, as well as a H-bridge motor driver. And then we have the two servos here, plus two more servos there for 4 servos at the top. And I'm thinking whether or not to just go back to my previous design of using the servos to do the position location, because the code was just so much simpler back then. So that's one of the things where it's probably helpful that I have the modular design on the bottom. So yeah, that's a work in progress, but here's where we are so far. Any questions or song requests? Yes.
Where and when is this Maker Fair?
So it's in the East Bay, which means Oakland, and it's October 27th on a Sunday, and it's that's where and when, and the rest is on the internet, I guess. Yeah? Okay.
Awesome.
Let's see, 2 months ago, I mentioned the fact that I was at the flea market the previous month, and there was a fellow there that was representing a new little company. They were starting a Kickstart. And so I talked to him a little bit, and I got really excited over what he was doing. Since they were going for $10,000, they ended up with $21,000. So somebody else must have thought that it was a pretty good deal too. So what I did is I ran home promptly and got into the Quick Start, and as a result, I ended up getting the Quick Start kit, which included this FPGA card. Okay, so I know some of you are doing things with FPGAs, and that's the actual card itself. Then, see, they raised $21,000. So they have this now out in a store that you can actually get this. And then for $75, you get all these little peripheral parts and pieces that makes it more fun to play with. Okay, so that's what he was talking about, and that's what they came up with. And sure enough, I received mine just as they said. Now, the thing that I find exciting about this is that all you have to do to program it is to take a cable. Let's see, can you go that side up? There you go. I can't see what that was. Okay, so it turns out one of the things that's neat about this, one of the things that's neat about this system is that all of the tools are on the web. So you don't have to download anything into your computer. You simply, let's see, is this where you can see it? Let's get this where you can see it. Okay, like that. Okay, so you don't have to load anything into your computer. You just have to plug it in. Now, I bring up this page, which is in this case, it's at betawebfpga.io. Now, to actually get it to do something, we can go here and look for all the example programs that are provided from the web. And then, if all goes well here, let's do the classical equivalent to the hello program for robots, right? Which is the Blinky program, okay? So let's load that. I can get it, yeah, Blinky. Okay, then let's run the synthesis. Let's see, so it's over here running at this point. Oh, it's ready to flash, so I think it may have already been in memory. Okay, so then we can connect the device. Just simply connect it, and now flash the device. There it's flashing, done, okay? And you can see, is it showing the blink? Okay, so that was all without any tools in my computer whatsoever. Okay, then let's do another quick one here, which is what I had set up. I can do the timer, okay? Run synthesis. Oh, it's ready to flash already. So they may have it already. Remember, if you make a change, which by the way, you can go in and change this if you want. Okay, so I'd have to connect the device again. Connect it, flash the device, and we're off and running again, right? And now at this point, did it come up with the zeros? No, yeah, right. Okay, as I remember, you start it over here like this. So that's the timer program. No tools at all in the machine. Okay, so for and you can actually put Verilog programs on your computer, and you can see down here, load local files. You can do that. And this is some information about what the FPGA, and oh, by the way, this is a lattice FPGA apparently, and those are the parameters. So if you want to get into the FPGA at least another way, I know there's a class that you're running where I think you're loading the tools on the computers. This is a way, by the way, the other thing you can do is you can program this from your Arduino cell phone. All you have to do is take that cable and plug it into the cell phone, or take the cable that will match into your cell phone, and you can go to the web page and program it. Okay.
Yeah, very nice.
So just remember,
FPGA, right?
Yeah, Web FPGA IO. And I'll have it running over here on the side if you want to talk after the break.
There's a question.
Okay. Okay.
Put the link on the web.
It's just go to webfpga.io.
Maybe if you post some information to the Google group, then people will have that.
Okay.
In case I can't remember.
Okay, I can do that. Okay, great.
Thanks.
All right. I don't work for this company, by the way. Yeah, I don't work for this company. I just got excited. I think it's a pretty neat product.
This is just a static display, just real quick, something I'm working on. It's a new bot. You might recognize the chassis. It's another Devastator. This one used to be Mike Wimble's. I traded him a Zuma bot for it. I had 2 Zuma bots. So now he's got a Zuma bot, so he has no excuse not to do the line maze. But anyway, so he gave me his old Devastator, so now I have 2 of these. And this one, you may recognize, has the scans LiDAR on it. They did a Kickstarter as well. Eventually folded, but I picked one up off the Kickstarter. I've been running it so far. It seems to work fine. I was talking with somebody in the back. The readings bounce around a little bit, so you get if you run their visualizer, you can see all the dots, and it looks great. You can also look at the table of the raw data, and instead of being real solid, like 0, 1, 2, 3, 4 degrees, here's the range. It bounces around and it skips some angles from time to time, and so the data is kind of moving around a little bit, plus or minus 5 degrees. So to really effectively use it, I think you would want to buffer that, copy it into a table or something. What if you get data on a certain angle, you put it into the array of that for that angle. So you'd have to buffer the data to really make use of it, I guess, but that's doable as long as you have some memory, which for me is always a challenge because I only use Arduino, so I only have 2 K of SRAM to work with, so we'll see how it goes. But anyway, that's the new bot, and we'll see. I've got the new motors and the Palolo motors in it as well to upgrade those Metal Gear motors with encoders, just like I have on Bile. So it should last pretty well. Get up and go, and I'm going to try and do Floorbot with this guy. Oh, and I forgot to tell you what the name is. I have kind of these weird names. He's my second Digesticon. So I was talking to my girlfriend about it, trying to come up with a new name. And she suggested Reflux. So that's the name of this guy. So, okay, thanks.
Nice.
So yeah, so this is the robot for a tabletop challenge for level 3. I'm supposed to find an object and push it into the goal. The goal, I'm using a Ruko symbol, and using a Raspberry Pi to find it, and then using the sonar to find the object. So let's see. It's not super complicated, but that's what happens. Okay. And it's not super quick. So, okay, here we go. So first it's using the sonar to find the object. Oh, we found it. Now it's using the Raspberry Pi camera to find the Ruko symbol, and then it just looks at where the Ruko symbol is to the middle of the frame and keeps going until it's closed the gap on that, and we'll drive forward. Oh, yep. I know it's a little close up. Yeah,
Did the job.
The further out I go, the probability goes down. I have to work on that as well. I should actually. The Ruko works the best. I should do that also for this, and it'd be a little more rock solid. But
is it the Raspberry Pi camera as well
yes.
that you're using there?
Yeah. So there's an Arduino on the bottom, A little bit of a mess of motors.
Hold it to the camera so the camera can see.
Okay. And little battery, my Raspberry Pi, and then the camera. Grabbers, which are also the IR things so it doesn't fall off the table.
Very good. We look forward to seeing that one again next month.
Okay. Yep.
Okay, who else has a robot? Chris, come on up.
Hello, most of you already know what this is. This is the MottBot, and I just wanted to, it's not running right now because I dropped it as usual, and it's this typical popsicle stick and super glue construction. But I just wanted to mention again, I have robot build days at my place, and because we're having a challenge next month, perfect for anybody who has not built one yet. It only takes a couple hours. You can build one of these. I actually have so many parts that anybody who shows up, you get parts for free. So just come up, build a robot. Includes software. And I don't know how many of you remember, but last year I gave a lecture actually running artificial intelligence on this guy. It's just an Arduino Nano, yes. And it learned how to do the tabletop challenge by itself autonomously. So if you either want to build a robot and just do a simple tabletop challenge, or if you want to get into some really ghetto at-home AI, let me know, and I'll put your name on the list to come by and build one of these things. So if you have any questions, come in and see me.
That's a great offer. How would people get in touch with you?
I post on the news group, and don't reply on the news group though, but reply to me separately, but I'll give all the information, the dates, the times, the addresses. And sorry, Danny, I don't mean to put you out of business by giving away free robots and free lessons. But I have so much inventory, I kind of want to get rid of a lot of it. So
He really won't be undersold.
I'm not going to pay anybody to show up.
Could have sworn somebody mentioned a check.
Right. Thanks, Chris.
So all the robots are at home, but I just was kind of excited about this little thing. This is a 24 IR sensor solar compass. There's also an accelerometer, and what's the point? I did put a magnometer on it, but what's the point if you're going to use the solar compass? It has a little OLED display. It's the same one you've seen on a bunch of my little robots and so forth. And when the shadow comes down, it hits one sensor or two sensors. So I have about a resolution of 48 positions around that I can detect. And I'm hoping to put it on Robo Magellan for next year when summer comes around again and we start doing that kind of stuff. Anyway, it's a little M0. It's the 070 M0. And a bunch of analog muxes, and then it brings them into the processor. The processor reads the readings, tries to make a decision as to, all right, which one is in the shade, or which ones are in the shade, and then it knows that the sun's on the other side, and it has a serial interface that I would then bring up to the Pi and so forth, so the Pi can make sense out of this. It's just the sensor. You would need to know, well, where is the sun? And, you know, that sort of thing. And then you have the Pi work out the math to figure out your directions. Anyway, that's it.
Cool. This is your own design?
Yes. Yes, it's another marktoys.com. But I don't sell any of that stuff. But if you're interested for a good time, go to mark-toys.com. You'll see all the projects. And I made it so it's a one-click interface. You just scroll to find something that looks kind of interesting or geeky enough, and then you click on it, and boom, it's on that particular project. And there's all kinds of weird stuff like Target Bot and all the Tightwire Bot that I did the circus thing on. All that kind of stuff's out there. Okay, thanks.
The Fiddler Bot.
Fiddler Boss, which was here last month.
Classic.
Thanks, Mike.